The solar system, as vast and magnificent as it is today, began as something much simpler, a massive cloud of gas and dust floating in space. Over billions of years, this cloud transformed into the sun, the planets, their moons, and countless other celestial bodies. Understanding how the solar system formed helps us not only learn about our own cosmic neighborhood but also how other planetary systems in the universe might come to be. The most widely accepted explanation for the formation of the solar system is called the nebular hypothesis. According to this theory, around 4.6 billion years ago, a large cloud of gas and dust, called a solar nebula, began to collapse under its own gravity. This collapse may have been triggered by the shockwave of a nearby supernova explosion. As the cloud contracted, it began to spin faster and flatten into a disk-like shape. At the center of this spinning disk, the material became so dense and hot that nuclear fusion began. This process ignited our sun, forming the central star of the solar system. Meanwhile, the remaining material in the surrounding disk began to clump together, forming what would eventually become planets, moons, asteroids, and comets. The process that formed the planets is called accretion. Small particles of dust and ice collided and stuck together due to static electricity and gravity, forming larger and larger clumps called planetesimals. Over millions of years, these planetesimals collided with each other, merging into even larger bodies known as protoplanets. Closer to the Sun, temperatures were too high for volatile gases like water and methane to remain solid, so the inner planets, Mercury, Venus, Earth, and Mars, formed from rock and metal. These are known as the terrestrial planets. Farther from the Sun, in the cooler regions of the solar system, ices could remain solid. This allowed planets to grow much larger, attracting massive amounts of gas and forming the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. These planets have thick atmospheres of hydrogen, helium, and other gases. As the planets grew, their gravity began to clear the surrounding space of debris. Some of this debris formed moons around the planets, while other leftover material became the asteroid belt between Mars and Jupiter, and the Kuiper belt and Oort cloud farther out. Over time, the young solar system settled into a more stable structure. The orbits of planets became more circular, collisions became less frequent, and the solar system began to resemble the one we live in today. Among all the planets formed, Earth developed unique conditions that allowed life to emerge. Positioned in the Goldilocks zone, not too hot and not too cold, Earth maintained liquid water on its surface, an atmosphere, and a magnetic field, all of which were crucial for the development and protection of